Hello, good afternoon, Professor. This is Gautam Kamesh Piratla. Student ID is 2129017. Today I'm discussing about my project, loan approval prediction using machine learning. So in this project, how I modified the data set and what are the machine learning techniques I use in this project, I will explain in detail. So when it's come to the what is loan approval prediction, mainly loan approval prediction is the first two process of determining whether the loan should be approved or denied based on the some factors like the income, credit history, and loan amount. And when it comes to the why it is used, like the loan approval prediction, in based on these three factors like financial impact, competitive, and different factors. And in the data set, I took the data set from the Kaggle, so which is named as loan approval prediction. It contains like 14 rows and 13 columns. Mainly these factors include like loan approval information, financial information, demographic information, and loan application information. By based on these factors, the data should be designed. So next I convert, I make some modifications in my data set. So I convert dependence to the object type and I convert loan amount to the numeric type and drop irrelevant column and identify categorical columns and create list of object type columns for encoding because it's data consistency, better performance and improve formally. So later I move on to the handling missing values. Mainly it is used for to replace the missing numerical values with the median and categorical values with the mode. So I use the Python code. Based on this Python code, I will check whether the no missing values remain. So the data set should be clean and it will be useful for the analysis. Later, I move on to the encoding categorical variables, so which is used for to require the numerical input data because machine learning is important to cannot process directly text or categorical data. So we'll encode the categorical data to the numerical data. So later we move on to the numerical, normalizing the numerical data, which is like to pre-processing step the scales numerical futures to a standard range, which usually between 0 and 1, or it's mean like mean of the 0 and standard deviation 1. So it is used to improve model performance, speed up convergence. So later we move on to the categorical columns, which is used to analyze the individual categorical columns and to understand the value distribution and the ratios. So I already mentioned in the graph, like the difference between both male and female, or else like married or unmarried. I mentioned everything in the graph. What are difference of both the so later we move on to the dealing with outliners, mainly divided into two types, which are like identifying outliners and visualizing outliners. Mainly it is mentioned in the box plot format. So we can see the box plot, how it is been designed for the various number of the columns like the application, income, co-application, and all the factors. So it would be easy for us. So after when it comes to the future engineering, I used future engineering for to creating the new features like income to the loan ratio, total income to provide model with more relevant information, and it's helpful for to understand the financial relationship between application income and the loan amount. So when it comes to the scaling in the machine learning models, it's perform the numerical features are on the same scale. I used the min-max scaling to help the numerical columns like application income and loan amount transferring these values range from between 0 and 1. So it would helpful for me to enhance the data set very much. So previously I discussed about the what is encoding, how it is been work. So there is two formats of encoding, which are the label encoding and the one-hot encoding. So label encoding is about the binary columns. It's transform the categorical values to the numerical values like 0 and 1. It is easy model interruption. And in one-hot encoding, apply numerical columns property area in different formats. When it's come to the future reduction is divided into the three formats, which is like mutual information, lasso regression, and final future selection. The mutual, it identified futures contribution to the loan approval. In Lasso, highlighted importance futures by thinking less relevant. In the final future, it's combined of the both MI, Lasso, and all the types. Finally, it comes to the machine learning algorithms. So in machine learning algorithms, the first machine learning algorithm I used is like logistic regression. To use it for the binary classification task, which where the goal is predict whether the loan important will be approved or denied in the input futures. And when I'm running this, I got some output values. So when move on to the random forest classifier, it is used for to the predict the loan approval status using the ensemble of decision trees. And random forest is reversed, handles both numerical and categorical values. And when I'm running this random forest classifier, I got the values. When it's moved on to the gradient boosting classifier, it is used for to predict the loan approval status using the boosting technique by building trees and sequentially. And gradient boosting is powerful for handling complex data sets and often provides better performance than the random forest maybe. So when it's moved on to the support vector mission, it's predict the loan approval status like using the hyperplane that separates approval and denied loans. And SVM is used to effective for high dimensional data and works with a clear margin of the separation. And it is the values, output values for the SVM. These are the output values for the SVM. And when later, finally, when it comes to the decision tree classifier, it is used for to predict the loan approval status using a single tree decision tree, or those decision trees are very simple and interpretable and work well for the small data set. So these are the values for the decision tree classifier output values. So by comparing all five machine learning techniques, for me, the logistic regression is very seems to be the best performing model because it has the high accuracy, high recall, and high F1 score, and finally the high cross validation accuracy. By comparing all this, the logistic regression has the better output. So finally, in the conclusion, I built a loan approval prediction by using the machine learning to start by cleaning and pre-processing the data and handling the missile values and encoding categorical variables with dealing with outliers. And after testing the different machine learning models, the for me logistic regression is the better because of the high accuracy and all the factors. So finally, for me, a model can help banks and financial institutions to make their loan approval decisions based on their applicant details. It can reduce in the risks and all the improving efficiency. So it would be helpful for all the banks to easy predict their loans and all the stuff. So this is about my project, which is the loan approval prediction. Thank you, Professor.